Why is light faster than anything else in the universe? Did you know that every time you look at the sky, you are literally seeing the past? That's because light, even though it's the fastest thing in the universe, still takes time to travel to us. But what if something could be faster than light? Could we travel through time, see events before they even happen? In this video, we will unravel the mysteries of light, how it manages to be so fast, what makes it different from everything we know, and why it's impossible for anything to surpass it, at least for now, and more. We will explore what would happen if we broke this universal rule. Get ready for a fascinating journey through the cosmos that will challenge everything you thought you knew about time, space, and our place in the universe. Stay until the end, because I'll reveal a curiosity that could completely change the way you see the stars in the sky and even the sun that shines every day. What is light? Light is an incredible form of energy that travels in waves, like the ripples you see in water after throwing a pebble. But unlike water waves, light doesn't need a medium like water or air to propagate. It can travel through empty space, carrying information and energy from one place to another, like a very fast messenger of the universe. In addition to being a wave, light is also made up of tiny particles called photons. These photons are like magical messengers that have no mass, meaning they weigh nothing. That's why they can travel at astonishing speeds without ever stopping, as long as they don't encounter any barriers. They carry energy and are responsible for everything we see around us. But did you know that the light we see, called visible light, is just a small part of something much bigger? There is a set called the electromagnetic spectrum, which includes many other types of light that our eyes can't perceive. For example, X-rays that doctors use to see bones, ultraviolet rays that can cause sunburn, microwaves that heat your food, and even radio waves that bring music to your car. Each type of light has a different wavelength, like musical notes on a scale. What is the speed of light? Light is one of the fastest things in the universe. In a vacuum, an empty space without air, dust, or any other particles, it travels at an impressive 300,000 kilometers per second. This means that in just 1 second, light could circle the Earth almost 7 times. To give you an idea of how fast that is, the light coming from the moon takes only about 1 second to reach our eyes here on Earth. Now, imagine a colossal racetrack where a Formula One car, a supersonic jet and light are competing. Before the car or jet could even fully accelerate, light would have already crossed the finish line and be kilometers ahead. This speed is not only fascinating, it's essential for the universe to function as we know it. The speed of light also serves as a ruler for measuring unimaginable distances in the cosmos. Scientists use something called a light year, which is the distance light travels in a whole year. Just so you know, light travels about 9.46 trillion kilometers in 1 year. When we look at stars and galaxies, we are actually seeing the light they emitted years, centuries, or even millions of years ago. For example, the light from the sun takes 8 minutes to reach Earth. This means that if the sun turned off right now, we would only notice it 8 minutes later. Similarly, when we look at a galaxy 2 million light years away, we are seeing it as it was 2 million years ago, because that's how long it took for the light to reach us. The speed of light is like the speed limit of the universe. It sets the maximum limits for how energy, information, and even natural forces can travel. That's why light is so special. It not only illuminates us, but also connects us to different points in space and time. Why is nothing faster? Albert Einstein revolutionized our understanding of the universe with his theory of relativity, explaining why nothing can be faster than light. According to him, the speed of light, about 300,000 kilometers per second in a vacuum, is not just fast. It is the universal speed limit. It's as if the universe had an imaginary sign saying, "Beyond this point, no one passes." This happens because of something curious about how energy and speed work. When you try to accelerate something with mass, like a ball, a car, or even a spaceship, you need to use energy. The faster the object goes, the more energy is required. So far, so good, right? But Einstein discovered that when trying to get close to the speed of light, the amount of energy needed increases absurdly. In fact, an infinite amount of energy would be required to push something with mass to that speed. And since infinite doesn't exist in practice, it is impossible to reach or exceed the speed of light. Now, photons, the particles that make up light, have a special advantage. They have no mass. This means they don't face the same resistance that objects with mass do. It's as if they are traveling downhill, weightless, and without anything to slow them down. That's why photons are born already traveling at the maximum speed allowed by the universe. Imagine a rocket trying to compete with light. No matter how powerful its engine is, it will always be limited by mass and the available energy. To double a rocket's speed, much more fuel would be needed, and that quickly becomes impractical. Meanwhile, light continues to be the speed champion, with no competition. This universal rule is not just a curiosity, it is fundamental to how the universe works. If something could travel faster than light, many things would become confusing, such as the order of events in time. That's why light remains the absolute limit, respected by everything and everyone in the cosmos. What is a vacuum, and how does it help light? The vacuum is like the emptiest space you can imagine. There is no air, water, particles, or sound. It is literally a complete nothing, where light can travel freely without encountering any obstacles. Think of the vacuum as a perfect, smooth road with no traffic. Light can speed through it at its maximum velocity, which is about 300,000 kilometers per second. However, when light passes through places with particles such as air, water, or glass, its journey becomes more complicated. In these environments, light needs to negotiate with the surrounding particles, colliding and interacting with them. This makes it lose speed, as if it were running on a road full of small stones or potholes. For example, inside water, light travels much slower, about 75% of its maximum speed in a vacuum. This happens because the water molecules hinder the photons of light, forcing them to change direction many times before exiting on the other side. That's why objects look distorted or out of place when you look into a pool or a glass of water. The same effect occurs in other materials, such as glass or crystal. When light enters them, its speed temporarily decreases. But as soon as it exits back into the air or vacuum, it regains its maximum speed. This slowing down doesn't change the nature of light, but it shows how it interacts with the surrounding environment. In empty space, where there is nothing to interfere, light reigns supreme, traveling at its maximum speed. But in dense materials, it demonstrates how the universe is full of complex interactions, which can even create beautiful phenomena such as rainbows or the sparkle of a diamond. The vacuum, a paradise for light. In summary, the vacuum is like paradise for light, where it can run without interruptions, while other environments are like challenging tracks that force it to slow down and change its path. How is light different from other things? Light is special because it doesn't need fuel, engines, or wings to move. While cars, planes, and rockets require energy to accelerate, light photons simply move because they are part of the natural laws of the universe. Another difference is that light has no mass, whereas everything we know, people, objects, and even planets, has some weight. Imagine you have to carry a heavy backpack. It slows you down. Now imagine you don't have to carry anything. That's how light travels, light, fast, and effortlessly. Additionally, light can travel through empty space, where there is nothing to push or pull it. On the other hand, a car or an airplane needs a road or air to function. This makes light incredibly efficient and unique. Why is this important? The speed of light acts as a universal clock. It helps scientists measure enormous distances across the universe and understand how things work. For example, when you look at the night sky and see a star, The light from that star may have traveled thousands or even millions of years to reach your eyes. If light was slower, the way we perceive the universe would be completely different. For instance, the sun appears to shine in the sky, but the light we see actually took 8 minutes to travel here. This means that if the sun were to turn off right now, we would only notice it 8 minutes later. That's why the speed of light is a key piece in understanding everything around us, from how stars shine to how galaxies move. What if something was faster? If something could travel faster than light, it would be like opening the door to a completely different universe full of incredible possibilities. One of the most fascinating ideas is that this could allow time travel. Imagine leaving a place and arriving at your destination before you even departed. It sounds like science fiction, but it's a theoretical possibility that challenges everything we know about space and time. The reason is that light is not just fast, it acts as the universe's time marker. All our physical laws are based on the idea that nothing can surpass its speed. If something could break this rule, the very concept of cause and effect could become scrambled. You could, for example, see the result of an event before it even happened, like watching a movie from the end to the beginning. Despite these exciting ideas, nothing we know can surpass the speed of light. Not even super-fast particles, like those accelerated in the Large Hadron Collider, which come close to the speed of light but never quite reach it. This is because the faster an object with mass tries to go, the more energy it requires. And reaching the speed of light would require infinite energy, something impossible in practice. For now, light remains the queen of speed, showing us how fascinating the laws of the universe are and leaving us to imagine what else might be hidden beyond the boundaries it defines. Want to know more about the mysteries of light and how it sets the pace of the universe? Subscribe to the channel and discover how this incredible speed connects space, time, and our lives.